In this assessment, we're asked to show how the dicarbonyl compound on screen can be made in two different ways. One, using ozonolysis, and two, using a process of dihydroxylation and then cleavage of the diol. Let's start with ozonolysis. I've gone ahead and numbered the carbons. Recall that ozonolysis is going to take an alkene and cleave that alkene, essentially inserting an oxygen between the two carbons of the alkene. What that tells us then is that the alkene is going to be between carbon 2 and carbon 6. Since the two carbonyls are held within the same molecule, that implies that this is going to happen within a ring structure. And so let's draw a 5-membered ring as shown here. The double bond is going to be between carbon 2 and carbon 6. We'll put that here, so we'll call that carbon 2, carbon 3, carbon 4, 5, and 6. Keeping that numbering, we note that carbon 2 has a methyl group attached. That's carbon 1. There's also a methyl group at carbon 3 and carbon 4. We can keep the stereochemistry correct by showing a dashed methyl at carbon 3 and a bold wedged methyl at carbon 4. This is the alkene that would undergo ozonolysis to give this dicarbonyl compound. We can use this same alkene to do our dihydroxylation reaction to make this same dicarbonyl compound. In this case, it would start with using osmium tetroxide. I'm going to only show one stereoisomer of the product, but we would expect to get two diastereomers. We'll draw the one where the two hydroxyl groups add to the top. And then once we've got these two hydroxyl groups on the same side of the molecule, we can now react this with periodic acid, which should result in cleavage to give the dicarbonyl compound here. Two different ways, starting from the same alkene, to make the same compound.